Hi, today we will discuss the types of engineering structures. We can classify five types of engineering structures: the frame structures, the shell structures, arc structures, mass structures, and cable suspension structures. As you can see, for the mass structure, I have shown it to you already, the Stonehenge. Also, we have the Great Pyramid of Pisa and a gravity dam. For the arc structures, you can see in nature the rock formation. Also, we have the Roman aqueduct. This is also in arc. This is still existing today. And also, we have this very beautiful bridge. It also carries the bridge using arc action. And the largest gateway arc in the USA. For the shell structures, you can see the UPAD. This is actually the concept of this is for a locust housing in Hong Kong. And also we have the shell house. It's the the roof and the wall are concrete except for the this here the view in inside, which is using glass. Also we have the shell structure, the Wolfgang Meyer Sports Center in Hamburg, which is the roof for the ice skating rink. Also, we have the cable suspension structures. This is the Sky Bridge in Russia. As you can see, or you can imagine, this is purely in tension. Also, we have the stress ribbon bridge construction, which carries, which use tendons to carry the whole structure in tension. Also, we have the Milao Viaduct, which is a cable-stayed bridge. Of course, we also have the frame structure, just like the warehouse using the structural steel, the residential commercial buildings using timber and structural steel, and the skyscrapers, as you can see, the the elements, the column and the beams and the slab. Also, we have the twisted building uh, group at the bay in Miami. As you can see, it's actually really twisted. This is a residential building, I think, and the concept is that the 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 core of the building at the middle, which houses the elevator, is used to carry the building, the gravity load and the lateral load. As you can see, the columns in the outer portion of the building is actually in tension, not in compression. So this is quite an innovative structural engineering concept. Also, we have some of the Zaha Hadid architects projects. So as you can see, here is the framing using frame structure and a shell. This is a combination of frame and a shell, and you can see the result. It's a really beautiful. Also, in the giant shape you can see the framing of the shapes. Ship are also using frame construction. Aside from that, the aircraft construction also use a frame construction. We have a circular frame, and then with the stringers, and then the floor beams. So with the wing of the airplane, we are using a frame construction. Also for the bridges, example the suspension bridges, the severed bridge, as you can see, uses the frame construction also. Of course, we have the a new way of designing super long suspension bridges. Here they are using the computational morphogenesis. Morphogenesis is the generation of or it's a biological process of developing a shape. So as you can see, here is the conventional girder design. This is truss actually. You can see the top and the bottom cords with the different waves. This is the blue, the conventional, but the red one is the result of computational morphogenesis. So it's not necessary that we have to design a straight girder. As you can see, you can use some curves. Look at the design concept of the conventional girder. So this is just like a matchbox with some divisions within. And of course, with this kind of design, this is quite uh, light. But of course, with the result of computational morphogenesis, this is more efficient and effective. A super long suspension bridges. That's all. Thank you for listening, and I hope you were able to learn some of the different engineering structures. But in our course, structural theory, unfortunately, we will only be discussing about frame structures. If we say frame structures, we have the structures coming from the top, the slab, then the slab is to be carried by beams. Beams are usually carried by girders, a larger beams, and the forces will be transferred to the columns, and the columns forces will transfer to the footing and then to the foundation, that is to the soil. So in that way, our discussion will be purely frame structure. Sorry for that. If you really want to learn about the other structures, you can study it in advance, or you can ask for books for that particular structures. That's all. Thank you.